It should be familiar. If you didn't do it, it should be familiar to you from what you did in your 7th or 6-3 homework. Switched. Okay? And then I'm going to solve for y to find the inverse. So I subtract 2 from both sides. And I get x minus 2 equals 4y. Divide by 4. And y equals x minus 2 over 4. So that's the inverse, but to be proper, I should write it as, oh no, I can just write it like that. They don't have f of x notation here. So that's how you would write it. Well, let's just be proper because it bugs me. Let's write f of x to the negative 1 equals x minus 2 over 4. And this would be f of x. Better to write it in proper notation. Original function, inverse function. Original function, inverse function. Okay, let's do this again. What?
I just said that's what the negative.
Yes, so here's the original function, f of x, which is really the same as y, your output. So I'm going to find the inverse. All I do is switch x and y. Switch, 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 and I just get y. Actually, y equals x minus 4. Subtract 4 from both sides. So this is the same as f of x to the negative 1. That's inverse notation. Equals x minus 4. So, finding the inverse is switching x and y. Interchanging the input-output. That's what you're doing. Questions on that? Doable? Okay. All right, so now what you're going to do is you're going to verify that this is truly the inverse of this. And what you have to do is, if they are, each composition will equal x. So you're like, what? This is what you do. You compose f of x to the negative 1. You compose them. Okay, and it has to equal x. If you compose them, they have to equal x. So let me show you what that means. Compose f of x1.
Oh,
See?
X.
Oh, she wrote it different there. The negative one's in the wrong spot. So this is what it's going to look like. I'm going to take f of 1/4 x minus 1/2. This is f of x to the negative 1. Composing. So I'm taking this and plugging it into f of x, so it's going to be like this. 4 times 1/4 x minus 1/2 plus 2. What am I going to get for that? What is that going to equal?
Plus 2.
Yeah, I took this and plugged it into there.
Why can't you just
Well,
do what you did for the stuff over there and see if it equals?
Yeah, we're going to do it right now.
Why would you
But why do you have to plug in all weird?
What do you mean? You're composing them.
Why did
So just do the math. And you get 1x minus 2 plus 2. And what does that equal? X. That equals x. So f of x to the negative 1 equals x. So yes, they are inverses of each other. Yes, that's what it says right here. Then they're not inverses of each other.
what is my final answer?
But
X.
How is that?
why couldn't you just
Why is that my
take,
final answer though?
f of x equals
So if I had an
y
x
plus
squared, it
2
would be
and
right?
then flip it and then like solve?
You could, but it won't always be that easy. You could. You mean just solve, flip and solve? Yes. But they're going to ask you to show this too, that you understand this concept, that you compose them to see if they actually equal x. Yes.
So if it equals, so if instead of 1x it was like x squared, that wouldn't be right?
Then they would not be inverses of each other.
What if it was 2x?
Then they're not inverses of each other.
It has to be 1x.
Has to equal x. Yes.
Not automatically makes it equal.
Right. Makes them inverses of each other.
But what is it in inverse of both those equations?
Like this is an inverse of this. Like if I were to switch x and y in here and solve for y, I would get that. If I were to switch x and y in here and
those two are inverses, and then the last one's an inverse of both of them combined?
No, this is just composing them. You just put one inside the other to see if it does give you a value of x. Like you did, see we did this right here. This is what we did. We put this one.
That they're inverses.
Exactly. It's a good word. Okay? Proving that they're inverses. Verify, right here. Verify or prove. Brian wants the word prove here.
Doesn't.
Prove.
Whatever.
Okay? So you put one inside the other and see if it equals x. If it does, then they're inverses of each other. All right, turn it over.
Does it matter which?
Nope. All right. A small company produces greeting cards. The cost C in dollars of producing N greeting cards per month can be modeled by this function, cost and number of cards. Okay? Find the inverse of the model. Now you have to be careful with this. Don't be switching the variables right now. Why could you not switch the variables when you're talking about a particular model? Because you're switching what they mean. Do not switch letters when solving for models. The letters are given specific things, so just solve for the other letter, and I'll show you what I mean. Just solve for the other letter. Find the inverse of the model. So here's my original model. C equals 360 plus 0.60n. So when you're working with a model, you just have to solve for the other variable. So I need n by itself here. So subtract 360 from both sides, and you get C minus 360 equals 0.60n. Divide by 0.6. We can make that a little prettier if we want to. N equals, I'm going to make this 1 over 0.6 C minus 360 divided by 0.6 is 600. It's okay. Simplified like that. So that's how it is. That's it.
We wouldn't turn that one into f of x.
No, all they want you to do is find the inverse of that one. You don't have, no, because n represents something in particular, so you don't want to switch it to f of x. Okay? N represents the number of cards.
So when it's a model, don't switch it. When it's just a problem, switch it.
Right. Okay? Use the inverse function to find the number of greeting cards produced in a month in which the company's total cost to produce the cards was $615. So all you do is what? Plug it in. Try it. Try it on your own. Plug in this for C. So N equals, I don't like this 1 over 0.6, but I'm going to leave it like that for now. And just do the math. Did you just ask him what the answer was?
Well, I don't have a calculator.
So you should get 425 greeting cards. Yeah, because that's what N represents. Okay? All right. When I got to this, I was like, what? There is not enough room in this little space to introduce what you have to know here. And it's not hard. I just wanted to make it in a little bigger space. So that's what this is. Okay, that's what that is. So there's a couple things you need to know here. And there wasn't enough room on that little piece of paper. So find the inverse, then graph both equations. Okay, here's what I want you to do. First thing I want you to do is let's put this in the calculator and get some points. We really don't need to put it in the calculator. We could do it by hand. But let's put x squared plus 2. That's my f of x. this is a restriction that we have to pay attention to on our graph, okay? So that's what that's there, and we'll get to that later. So let's put x squared plus 2 on here and graph it. Yeah, it's a parabola. Hopefully you all knew that, right? That shifted up 2. It's a parabola. Let's get some points off the table. Let's just do some simple points like -2, 6, -1, 3, 0, 2, and 1 and 3. I just took those right off the table. Yeah? I do want to plot these specifically, though. Plot these on the graph specifically. So -2, 1, 2, 3, 4, 5, 6. That's -2, 6. And then kind of sketch the parabola. Now there is a restriction, and I'm not going to talk about that quite yet. First thing I want you to remember, how do you determine, does anybody remember the test to help you determine on a graph whether a function is a function? What's it called? There's a test. Something to do with vertical line test. Do you remember that?
Oh, God.
Oh, I know. Well, this is a function. We can tell that by it passes the vertical line test. For every input, there's exactly one output. That's what it means, okay? Now, there's also a horizontal line test. So what that does for me, and this is new to you, is if I drew a line here, this way, horizontal, does it pass the horizontal line test? Huh? No, it doesn't, because it hits it twice. No. If it does not pass the horizontal line test, that tells me that the inverse is not a function. Tells me that the inverse will not be a function. Or it won't pass the vertical line test. It's just a little piece of knowledge that you need to know a little later. So it's good to know. If your original function doesn't pass the horizontal line test, your inverse function will not pass the vertical line test. Will not be a function. Okay, now, we're going to graph the inverse. What did I do on the other side to get the points for the inverse? What did I do? Switch x and y. Switch x and y. So let's do that. 6, -2, 3, -1, 2, 0, 3, 1. I switch the x and y. And then plot those points. And then look what it looks like. It's kind of cool. Look at it. It's like, this is the beautiful part. It's like a reflection over y equals x. It's a reflection over y equals x. Because we found out when they were inverses that y equals x. That's what we found out. Now, this does not pass the vertical line test, right? We determined that. We said, okay, this is not going to be a function. We already know that. Does f of x to the -1 pass the vertical line test? No, it's not a function. Therefore, there has to be a restriction, and that's what this is. That's why they brought that in. So, I'm only going to graph the parts of the function and its inverse that meet the requirements. So look at this right here. This part is where x is less than 0, correct? Yes? Then I'm going to include that part on my final graph. This is graph without restriction. This is going to be the graph showing the restriction. So I'm going to graph this part starting at 2, 0. This is part of the allowable function. and I'm going to graph that part's reflection. See, this is 0, 2. This is 2, 0. So I'm going to graph that. And this is negative 1, 3, sort of. So I'm going to graph 3, 1, 3, negative 1. So can I only graph the allowable parts of the function based on the restriction? That's the graph of this. Because I can only have the allowed part, which is this and this. It's reflection. This meets this requirement and the reflected part of that. That's all I can have. Okay, the inverse that meets that requirement also. And then if you want to draw this y equals x, you can. You don't have to. So that's it. It's really not that bad. You graph the original part, the part that meets the restriction, and here it was, x is less than or equal to 0. And then you graph the reflected part of that piece. Does that make sense? Practice it. It'll make sense. I promise. Let's do this one right here. So if I were to graph this on the calculator, I don't want to get all these points because they're funky. Let's do this on the calculator. Y equals 1 divided by 27 x to the third. Let's see what that looks like. Does anybody know, is it going to be a parabola or snake? It's going to be a snake. Let's graph it. Okay, so I'm going to do this one in pink. So it looks like this sort of. I'm just going to sketch it. Let's just sketch it, because the numbers are really funky on this. Hey, does that pass the horizontal line test?
Yeah.
Yes, so that tells me its inverse will be a function. There's no restrictions on here. Okay? So I'm going to solve for the inverse. I'm just going to show you what it is. I'm switching x and y. X equals 1 over 27y cubed. When I solve for it, y equals the cube root of 27x. I'm skipping a bunch of parts just to get to that point. Well, all you do is multiply both sides by 27 and then take the cube root. Right? That's what you do. Now let's graph this. Does anybody have any idea what do you think it's going to look like? Is it going to be a snake or a parabola? A snake. And it's going to be reflected over this y equals x. So let's just take a look at what it looks like on the calculator. Okay. So I'm going to do math cube root, which is number 4, of 27x.
Oh, it's flipped.
Yeah, so here we go. So there it goes. It kind of comes like this. Yeah. That's sort of what it looks like. Does that pass the vertical line test? Yes, it is a function. So there are no restrictions. So that's what it looks like. You can graph the whole thing. No restrictions. All right? We're not doing this last one. All right, determine whether the inverse of the function, this one's pretty easy. So here you do. Determine whether the inverse of the function f of x equals 3x to the fifth minus 2 is a function. Then find the inverse. Okay, when I typed this a couple weeks ago, this was not right. So cross that off. What you do is you check if f of x passes the HLT, horizontal line test. Check if f of x passes the HLT. If yes, then the inverse is a function. It's kind of what I was talking about already. If f of x passes the HLT, horizontal line test, then it is a function. So all I'm going to do is I'm just going to do a quick check on this function, is it going to be a snake or is it going to be a parabola? A snake. Let's take a look and see what it would look like, just to be sure. More than likely it will pass it, but let's just check. Oh, be careful on your calculators. These things are kind of picky. Okay, it looks sort of like this. Does it pass the horizontal line test?
No.
Yes. Passes the HLT. Then it has an inverse, and then you do the math to find the inverse. If it doesn't, then you don't have to. Tells you that the inverse is a function. Okay? So yes, it passes the HLT, so I have to find the inverse of f of x. I got to find the inverse of that. Okay? So I'm going to switch x and y. And then solve for y to get my inverse. X plus 2 equals 3y to the 5th. I'm going to go up here. I'm going to write this over here. 3y to the 5th equals x plus 2. Divide both sides by 3. Y to the 5th equals x plus 2 over 3. And how do I finish this problem? The 5th root. Right, Brian?
I made it a cube root for some reason because I divided the 3 and then I put like 3 there to pad though.
Okay, but I don't want to leave it as y. I should rewrite it as what? F of x to the negative 1. F of x to the negative 1. I'm going to cross that off and write f of x to the negative 1. That's my inverse right there. Basically, you're switching x and y to find inverses. You're determining if a function has an inverse function by the graph. You're graphing based on the restrictions. That's all. That's really what it's about. Okay.
Is the restriction